Good morning, everyone. Welcome to this lecture. This is lecture number 6 in center of mass. What did we discuss in the last class? Tell me what we were discussing in the last class. Anyone remembers?
Of mass of bodies with holes.
We were discussing the center of mass of bodies that were truncated or they were having holes, and we had seen that to find out the center of mass of such bodies, what we got to do is we need to superimpose two bodies, one complete body of full mass, and then we impose a negative mass on top of it, and that is how we can get the center of mass. Everyone remembers it? Yes or no? We had seen the question where we had a disk with a hole. We had seen a question where there was a spherical hole in a sphere. We had seen the case where it was a square plate and one part of the plate was missing. Anyways, in today's class, what we are going to do is we are going to move ahead and look into something known as the motion of the center of mass. Motion of the center of mass. What do we understand by the motion of center of mass? Yes. What do we understand by the motion of center of mass? What do you mean by motion of center of mass? Yes? Anyone? We had seen that we can find the position of the center of mass by this formula. R vector is equal to summation of mi vector divided by summation of mi. Do we remember this? Yes or no? Do we remember this? Yes or no?
Sir.
Okay. Now, if we differentiate this equation with respect to time, what do I get? If I differentiate this equation with respect to time, what do I get? I get the velocity of the center of mass. So what will be the velocity of center of mass? It will be summation of mi vi vector divided by summation of mi. Yes or no?
Yes, sir.
That is the way you can find out the velocity of center of mass. If I differentiate it once more, then what will I get?
Acceleration.
I will get the acceleration of center of mass. Do we understand this? Now, by finding the velocity of the center of mass and by finding the acceleration of center of mass, we can go ahead and do the other things. Let us first see a couple of examples where we find the velocity of the center of mass, and then we will move ahead and see how we can do the rest of the things. So this is one question where I would ask you to find out the velocity of the center of mass. Let me put that question for you. So this is the question. It comes on your screen now. A jeep of mass 2400 kg is moving along a straight road at 80 kilometers per hour. It is followed by a car of mass 1600 km per hour moving at 60 km per hour. How fast is the center of mass of the two cars moving? So basically, you have to find out the velocity of the center of mass. Can you do this question? I'll give you 1 minute, 2 minutes to solve it. So how are we supposed to find this? Oops. How are we supposed to find this? Yes, we just have to find the velocity of the center of mass. And why this pen is so dark? Something is wrong. Okay. How do I find the velocity of center of mass of this pen? This is good. I just add the velocities multiplied by masses. So the mass of the first of them is 2400. Multiply 2400 by 80 kilometer per hour. I add 1600 multiplied by 60 and I divide it by the total mass. The total mass is 2400 plus 1600 and I get my answers. Do you understand this? I think the answer is 72 kilometer per hour. Everyone got this? Yes or no? Okay. As you can see, this is quite simple to get this. Let us try one more. Everyone got the answer? Not getting response from the other center. Are we there, beta?
Sir.
We got the answer.
Sir.
This is the next question that we are supposed to do. A 2 kg particle has a velocity given by this vector. A 3 kg particle has a velocity given by this vector. You have to find out the velocity of the center of mass and I'll give you 2 minutes to give me the answer. So, how are we supposed to solve it? You just have to put the formula. Velocity of the center of mass is nothing but m1. M is 2. 2 multiplied by 2i minus 3j plus 3 multiplied by I plus 6j divided by 2 plus 3, that is 5, and you get your answers. Yes or no? No, yes, everyone got this? Everyone got this? Yes or no?
Sir.
Okay. Now, let me ask you this question. The next question, let me see if I have. No, I don't have. I will make this question for you. Question number 3. I have this Axworth machine. I hope you remember this Axworth machine.
Sir.
Do you remember the Axworth machine? M1, M2. The value of acceleration due to gravity can be taken as g. You have to find out the acceleration of center of mass of this Atwood's machine. To find out the acceleration of the center of mass of this Atwood's machine, and I'll give you 2 minutes to give me the answer. Everyone understands the question? Yes or no? 2 minutes you have for the answer. How
12
are we
m1 plus
supposed to
m2.
solve this? I did not tell you which mass is bigger, so let me assume that M2 is bigger than M1. So what will happen here? This will move down This will move down with an acceleration a, and this will come up with an acceleration a. Yes or no? Do we understand this? Yes or no? We understand this?
sir,
Okay, I have to find out the acceleration of this body. What is the acceleration a equal to? It will be m2 minus m1 into g divided by m1 plus m2. Yes or no?
yes, sir,
So what is the acceleration of center of mass? Let me call this acceleration as a. So I will write it like this. This will be equal to, if I take the downward direction as positive, it will be m2a. Upward direction would be the negative minus m1a divided by m1 plus m2. Do we understand how I've got this? Yes or no? One acceleration is upwards, one acceleration is downward. If you take upward as positive, it will be m1a minus m2a. If you take downward as positive, it will be m2 minus m1 into a. You put the value of a in this equation from here and you will get your results. We understand this? Yes or no? Okay. So as you can see, these questions are pretty simple. If you understand these questions, what you have to do is just do the same thing that we have been doing to find out the coordinates of center of mass. You can find out the velocity of the center of mass, or you can find out the acceleration of the center of mass. Nothing has changed. Now, let's take a step further and move into the next point, which is momentum. Momentum of the center of mass. What do you understand by the momentum of the center of mass? Now, what do we understand by the momentum of center of mass? Anyone has any idea? What do we understand by the momentum of the center of mass? Momentum of the center of mass. Now, what we have seen is the velocity of center of mass is given by summation of mi vi vector divided by summation of mi. We have seen this, yes or no? Now, if I just superimpose this summation of mi, which is nothing but the total mass of the, remember this summation of mi is nothing but the total mass of the system. Do we understand this?
sir,
Summation of mi is nothing but the total mass of the system. So I can write this entire thing as m into velocity of center of mass of the system. Total mass of the system into velocity of the center of mass of the system, and this is nothing but the momentum of the system of particles, or the momentum of the center of mass of the system of particles. Do we understand this? Yes or no?
sir,
This is known as the momentum of the system of momentum of the center of mass, or the momentum of the system of particles, momentum of the center of mass of the system of particles, that becomes equal to summation of mi vi vector. Now this mi vi is nothing but the summation of But this MIVI is nothing but the momentum of individual particles. So the momentum of the center of mass of the system actually becomes the summation of the individual momentum of the system. Do we understand this? Everyone understands this? Yes or no? And this is a very important result that we have got from here. The momentum of the system of particles, the momentum of the system of particles is nothing but equal to the momentum, the sum of momentum of individual particles vectorly. So wherever we have found out the velocity of center of mass, if we had not divided MIVI by M, we would have got the momentum of the center of mass or momentum of the center of mass of the system of particles. Do we understand this? Yes or no? Now, just wait a minute. I'll give you time to write. Don't write it now. I'll give you time to write. Now, if you've already seen that, differentiate this equation once more, I get the acceleration of center of mass, which is summation of mi ai vector divided by summation of mi. Yes or no? Now this summation of mi ai, this summation of mi ai will be the summation of the total force acting on the particle divided by summation of mi. Do we understand this? Now
Sorry.
this force acting on individual particles can be due to external region. It can be because of interaction between the two particles. Now when this interaction between the two particles, the two forces will be equal and opposite. These two forces that will be equal and opposite will cancel each other out. Yes or no? Therefore, the summation of Fi will simply become the net external force. So all the other forces will get cancelled, and what we will have is the net external force acting on the particles divided by the total mass. So from here I can write the external force acting on this system of particles will be m into the acceleration of center of mass. These two are very important results that we have achieved for the center of mass. The first one is the external force acting on the system is m into acceleration of center of mass, and the second one is, I'll give you time to write, don't worry. And the second one is that the momentum of the system of particles or momentum of the center of mass is summation of pi. These are two very important things that are going to come for a very long time. I'll give you 2 minutes to write this down. Everyone has understood this, yes or no? I'll give you 2 minutes to note this down. Okay, then. Now we have come till this stage where we have understood. Now, if I go ahead and if I see if the external net external force acting on the system of particles is zero, then what will happen? Then what will happen?
Acceleration 0, sir.
Then the acceleration of center of mass would be zero, or then I can say, the momentum of the system will remain constant This law is known as law of conservation of momentum. Law of conservation of momentum for a system of particles. Before going into that, I can just add some things here so that you understand. F external is m into ACOM. Now I can write this m ACOM. You can just add on to that as m multiplied by d by dt of VCOM. Yes or no? Right? So basically, do we understand how I written this? Then I can write it as d by dt of m into VCOM because m is constant. So that becomes d by dt of momentum of the system. You can just add this line so that it becomes quite simple, that if external force acting on the system of particles is zero, the acceleration of the center of mass becomes zero, the momentum of the system will remain constant. This law is known as what? This law is known as law of conservation of linear momentum for a system of particles. Do we understand this? Law of conservation of linear momentum for a system of particles will state that if the net external force acting on a system of particle is zero, the momentum of the system of particle will remain constant, or you can say the velocity of center of mass of the system will remain constant. Do we understand this? This is exactly similar to the law of uh, we have to understand this because we have not done law of conservation of linear momentum. We have understood this law of conservation of momentum for a system of particles. If there is one particle, it will become the law of conservation of momentum for one particle. If there are two particles, law of conservation of linear momentum for a system of particles. Do we understand this? Yes or no? Okay, I'll give you 2 minutes to note this down. Okay, then we move ahead. We have seen that if the net external force acting on a system of particles or on any particle is zero, that becomes law of conservation of linear momentum. I will call it as LOCM, law of conservation of momentum. Law of conservation of momentum. So what does law of conservation of momentum states? It says that if the net external force acting on a system is zero, the momentum of the system remains constant. Okay. Now, there can be different cases where we are going to apply this law of conservation of momentum. Now, in most of the cases, what is going to happen? So you can write it as important point, in fact. Now, law of conservation of momentum, if the net external force, so we can write it again. If the external force acting on a system of particle is zero, it implies that momentum of the system of particles is zero, which implies that acceleration of center of mass is zero, or the velocity of center of mass is constant. Now, acceleration of center of mass is zero. You can write if the center of mass is at rest, it will remain at rest. if the center of mass is moving with constant velocity, it will continue its motion. If the net force acting on a system of particles is zero, the velocity of the center of mass remains constant. The acceleration of the center of mass becomes zero. The velocity of center of mass remains constant. So center of mass will keep on continuing its original motion. If the center of mass is at rest, it will remain at rest. If the center of mass is moving with a uniform velocity, it will continue its motion with uniform velocity. Do we understand this? Now, we can see this in a couple of examples. Let us see the examples where the center of mass is at rest. The center of mass is at rest. If the center of mass is at rest, it will remain at rest. But the center of mass remaining at rest does not mean that all the particles are at rest. The particles may move and have non-zero momentum. So, if the center of mass of a system of particles is at rest, that does not mean that all the particles are at rest. Obviously, if all the particles are at rest, the momentum of center of mass will be a, zero, or the velocity of center of mass will be zero. But it may also happen that the particles are moving with different velocities, but still the momentum of the center of mass is zero and the velocity of center of mass is zero. Do we understand this? Let me give you an example. When can the momentum of or the velocity of center of mass can become zero? If all particles are at rest, the velocity of center of mass is zero. The center of mass is at rest. If there is no external force acting, it will remain at rest there. Do we understand this? Now, a second case and a very important case here where the particles are moving but still the center of mass is at rest. Now look at this example. Here I have two bodies. The pink body moving like this and the green one moving like this. Now, if I find out the momentum of this pink body, it will be 4 kg meter per second. Yes or no? But that will be in the forward direction. If I find the momentum of this body, it will be same 4 kg meter per second, but it will be in the negative x-axis. If I find out the momentum of the entire system, the momentum of the entire system will come out to be zero. Yes or no? But you can see here, even though the particles are moving, the center of mass is at rest because the velocity of center of mass is zero, because the momentum of these particles are cancelling out each other. Do we understand this? Yes or no? Okay. I'll give you one more example and then I'll give you time to note them down. One more example which comes in this particular case is a bomb exploding. Now, if a bomb is at rest and it explodes, let us say that this is the bomb. It is at rest, it explodes. It explodes into two particles. Now, it explodes because of internal forces and there is no external force. Before exploding, the bomb is at rest, therefore the velocity of center of mass would be 0. We understand this? Before exploding, the bomb is at rest. So the velocity of center of mass of this entire bomb is at rest. The velocity is 0. Now, if it explodes into two parts, let us say one part moves with a one part of mass m moves with a velocity v1 in the forward direction. Then the other mass has to move backwards. Let me write it. Let me draw it with a different color. It explodes into two halves. One half moves forward, the other half has to move backward, and they will move in such a way that the total momentum of the system is still 0 because there is no external force acting on the bomb. If the momentum of one particle is here like this, the momentum of second particle will be in the opposite direction with the same value. Do we understand this? So this is the case. These are the cases of three cases of the momentum of the center of mass being 0, or momentum of the system of the particles being 0, or the velocity of center of mass of the particle being 0. We understand this? Give you 2 minutes to note it down. One more case which you will find is this one where two people or two person, they're standing on a boat or on a platform and they start moving towards each other. In that case also we will apply the same principle. Two people are standing on a platform. The platform is at rest. These are questions basically which are going to come, and they start moving. So the initial momentum is 0, and therefore the final momentum would be 0. The center of mass will remain at its original position. Do we understand this? This is also one more example of velocity of center of mass is 0. We will be solving problems on this in the next class. So you just go through these examples where, and I'll in the next class we'll solve question on this and see how we can get answers from this concept. Everyone has understood the concept of this momentum of the center of mass, yes or no? If the net external force acting on a system of particle is 0, the velocity of the center of mass will remain constant. That is all that we need to remember in this. Everyone understands this?
Sir.
Okay, then I'll see you in the next class tomorrow, and we will go ahead and solve some problems on this. I would require you to please study and come in the next class. I think you are now preparing because today I found out that you were able to get the questions quickly. That is good. That is a good sign. But you have to continue this from now onwards. Read this and come in the next class. Otherwise, next class you will not be able to understand anything. This is a slightly difficult topic, and therefore you will have to come prepared. Do we understand this?
Yes, sir.
Okay, then I'll see you in the next class tomorrow. Take care. Have a nice day. Come prepared in the next class. Okay.
Thank you, sir.
Bye bye.